Okay, in this part, we're going to use the factoring method to solve for our quadratics, to find where they cross the x-axis. So sometimes you need to know which method to use. And so here are a few indications of when to use the factoring method. Okay, let's take a look at example 1. Notice that our y has already been replaced with 0. So we plugged in 0 for y, or f of x, and now we're solving for x. We want to know what value or values that x can be to make the left side equal the right side, which will be where this parabola would possibly cross the x-axis. So we're going to use the factoring method. So we need to rewrite our equation with 4 terms. So I'm still going to use my graphic organizer, and I'm going to say A times C is 10 and B is 7. The two values that multiply to give 10 and add to 7 is going to be 5 and 2. So I'm going to rewrite our equation with x squared plus 5x plus 2x plus 10 equals 0. We're going to group the first two and the last two, and we're going to factor out the GCFs. Now we have x plus 2 times x plus 5 is equal to 0. Now here is where the new process begins. We're going to set each of these binomials equal to 0. We're going to have x plus 2 equals 0, and we're going to have x plus 5 equal to 0. And now we're going to solve to see what the x value is going to be. So one intercept is -2. The other intercept is -5. So we can write our solutions -5 and -2. Or you could just write -5, -2, or you could write them as ordered pairs. These are the two places that this parabola, this quadratic function, will cross the x-axis. Let's take a look at another example. Let's see how we're going to split 9x. We have 8 and 9, so 8 and 1 will be the two factors we use to rewrite this equation. We're going to group, and we're going to factor out. Here we have x plus 8. It looks as though there's no common factor, so there is, and we're going to use it. It's 1. So the two binomials are x plus 1 and x plus 8, and they equal 0. So we set each of these binomials equal to 0. This is where our parabola will cross the x-axis. One intercept is -1. The other intercept is -8. So -8 and -1 are our solutions. Let's try one more like this. Again, we're using the factoring method by grouping. 1 times 35, and we have -12. We're going to use -5 and -7. X squared minus 5x minus 7x plus 35 equals 0. Now we set each of these binomials equal to 0 and solve. One intercept is +7. The other intercept is positive 5. Here are our solutions, our zeros, our roots, where this function crosses the x-axis. We have negative 48 and we have negative 2. Let's use 6 and negative 8. And now let's group. Factor out the GCS. Create your two binomial factors. And then set each of these equal to 0. We're solving for x when y is 0. Remember, when y is 0 and you're solving for x, that is your x-intercept. So one x-intercept is positive 8. Our second x-intercept is negative 6. Our two solutions, our two real solutions, are negative 6 and 8. Okay, I like this example because notice that our constant value of 42 is on the right side. We need this to be equal to 0. So we're going to subtract 42 to have every term in the correct place to solve for our x-intercept or intercepts. Now, I believe that that 3 is our GCF. So don't forget, always factor out a GCF if there is one. And 3 into 42 is 14. Now, don't forget, 3 is going to be one of our factors, so we have to keep bringing it down. So now we have 1 times negative 14. We have positive 5. So we're going to have negative 2 and positive 7. 3, and then we're going to rewrite this trinomial, x squared minus 2x plus 7x minus 14 equals 0. Again, this is going to be our x-intercept when y is 0. So our three factors are 3, x plus 7, and x minus 2 equals 0. So now we have 3 factors to set equal to 0. And we solve. Well, 3 equals 0 is false, so this is not going to give us any information. So one intercept is negative 7. And our second solution is 2. Now remember, we know that we were only going to have at most 2 real solutions because the degree of a quadratic is 2. So even though we have 3 factors, we only have 2 solutions. Okay, here we do not have a constant. So we see that we have a GCF of x. So we're going to factor out an x. So we have 2 factors, x and x minus 5. So we're going to set each of those equal to 0. So we can see that one solution is 0. So this quadratic passes through the origin. So 0 is one solution, and 5 is the other one. So our 2 solutions are 0 and 5. Here's another example where you don't have a constant. So when you don't have a constant and you have your quadratic and your linear term, you're going to have a GCF of at least x. Then we're going to set each of those factors equal to 0 and solve. This one is already solved for us. So again, This quadratic passes through the origin. It also passes through -8 on the x-axis.